Hello everyone, welcome to another video on differential calculus. In this video, I want to look at the binomial theorem and the power rule of differentiation. In the previous video, I did look at the factorial notation which is needed for us to understand the binomial theorem. So I'll go straight into it. Now, starting with the binomial theorem, what does it say? Okay, so we're starting with binomial theorem. Basically, it says, and I put the paper in landscape format because it's quite long. So I'll start from the far left. It basically says if I have x plus h to the power n, binomial theorem says this must be equal to the sum from k equals 0 up to n of n factorial all over n minus k factorial times k factorial of x power n minus k and then h power k. Now there are restrictions on k and n. We know that k must be an element of whole numbers, and the set of all whole numbers is basically 0 and then natural numbers 2, 3, I'm going to put there 4, 5, 6 and so on. All right, and then we also have n is an element of natural numbers, and natural numbers are whole numbers, positive whole numbers basically. So we're only excluding 0 there. So that these are the restrictions on k and n. N is a natural number and k is a whole number, right? So that's basically what the binomial theorem says. So now I am going to work on this expression for k from 0 up to 4. I put 3 here, 0, 1, 2, 3, but I'm going to stop at 4 because of space on my page here. So let's call this page 1 then. Page 1. Now, like I said, I'm going to take k values of 0 from 0 up to 4. So now I'm going to say here, for k starting from 0, then 1, 2, 3, and I'm going to add to 4, only up to 4. What do we have? We have, starting with that, so we have x plus h, the power n will be equal to, remember now, n factorial all over k is 0. That's the first one we're taking. So it will be n minus 0 all factorial times 0 factorial. And then we have x power n minus 0 and then h power 0. And then I'm going to say plus. Now we're done with that. We're taking k equals 1 now. Remember, the sigma notation means we must add. That's why I'm putting a plus sign there. And then I'm going back to the whole process. I'm going to put 1 here, 1 there, and 1 there now, and 1 there. So I'm going to say n factorial all over n factorial all over n minus 1 factorial times 1 factorial, and then x power, this one here, n minus 1, h power 1. And then I'm going to say plus. I'm coming to n, k equals 2 now. So n factorial all over n minus 2 factorial times 2 factorial of x power n minus 2 h power 2 plus. Now I'm coming to k equals 3, n factorial all over n minus 3 factorial and then times 3 factorial of x power n minus 3 h power 3. And the last part is n factorial all over n minus 4 factorial times 4 factorial of x power n minus 4 h power 4, and then plus 1, 2, 3. I told you I was going to stop at k equals 4. Now let's clean this up. Cleaning it up, we're coming to the second step here. The second step, we're going to say, so here I have n factorial all over n minus 0 is n factorial times 0 factorial is 1, if you remember from the previous video. And then we have x power n, because n minus 0 is n. H power 0 is 1. So I'm going to say times 1 here, plus we're here now. Now notice in the denominator I have n minus 1. So I'm going to have to expand that part there, the top part. So I'm going to say n minus 1, and I'm going to say factorial all over, we're here, n minus 1 factorial. 1 factorial is 1. If you remember in the previous video, that's 1. And then we have x power n minus 1. H power 1 is just h, plus. I'm here now. Here I have n minus 2, so I'm going to have to expand that, include a few more terms on the n factorial. So it will be n minus 1, n minus 2. And then I say factorial all over n minus 2 factorial times 2 factorial is 2, if you remember in the previous lesson. And then of what? Of x, that part there, n minus 2 h power 2, plus this part here, because of n minus 3, I'm going to have to stretch this up to n minus 1, n minus 2, n minus 3 factorial all over n minus 3 factorial times 3 factorial is 6. If you remember, 3 times 2 times 1 is 6. We have x power n minus 3 h power 3, plus the last part now. The space there is not sufficient, so I'm going to write it here, the last term. And I have n minus 4, so I'm going to stretch n minus 1, n minus 2, n minus 3, n minus 4 factorial all over n minus 4 factorial times 4 factorial. If you remember, 4 times 3 times 2 times 1 is exactly 24. So this is times 24, and then we have x power n minus 4 h power 4, plus 1, 2, 3. In other words, the terms continue. Right, now let's simplify what we see here. Notice that this cancels that. So this is going to be 1 over 1, which is 1. And the whole of this term, therefore, simplifies to x power n. All right, plus this part, you notice that this term cancels that term. So the whole of this term simplifies to n x power n minus 1 h, plus here you can see that term cancels that term. So we have n minus 1 all over 2 of what? Of x power n minus 2 h power 2, plus we are here now. Notice this term cancels that term. So we have n minus 1, n minus 2 all over 6 of x power n minus 3 h power 3, plus this part that cancels that, and so we have n minus 1, n minus 2, n minus 3 all over 24 of x power n minus 4 h power 4, plus 1, 2, 3. So this is basically what the binomial theorem says. Now I want you to check something here. When n is equal to 1, this part here collapses. because there it will be 1 minus 1 is 0. 0 times n, which is 1, is going to be 0 over 2. 0 times whatever, it will be 0. That will be 0 because it also has n minus 1. This term will also be 0 because it has n minus 1. So all the terms will collapse when n is equal to 1. But when n is equal to 1, what does it simplify to? It simplifies to x power 1 plus 1. Remember, x power 1 minus 1. X power 0 is 1 times 1 is 1 times h is h. And then it will be x plus h, which makes sense because when you raise x plus h to the power 1, you just get x plus h. Now, when n is equal to 2, you notice from here, these terms will all collapse because each one of them has n minus 2. So you are going to have only 1, 2, 3 terms when n equals 2. So all these will collapse because of that part there and that part there. Now, so it means you only have how many terms? You only have 1, 2, 3 terms. And when n equals 2, this will be x power 2 plus 2x. 2 minus 1 is 1, so it will be 2xh. And then n equals 2, that will be 2 minus 1 is 1, times 2 is 2 over 2 is 1. And then 2 minus 2, 0. X power 0 is 1. And then the whole of this collapses to h squared. And we know that x plus h to the power 2 is x squared plus 2xh plus h squared. Convince yourself that when you raise this to the power 3, you're going to obtain the expression I showed you in the previous video. Right, so the binomial theorem works. What I want us to look at now is to go straight to the power rule of differentiation. So let me remind you what the power rule says. So the power rule says if f of x is equal to x power n, then f prime of x is equal to n x power n minus 1. This is what power rule is. And for us to prove this, we're going to need this expression here. That's why I've had to teach you the factorial notation first. In the previous video on combinatorics introduction, we looked at the factorial notation. And then in this video, we started by looking at the binomial theorem, which basically breaks down into that expression there. Now, in this one, as you can see here, we're going to need that expression because in first principles, you deal with x plus h to the power n, whatever n is. All right, so let's look at the proof then. It will take me to the next page. I'm still going to need this part here. So if I put it here, I'm trusting that you're able to see it all. I'll just bring it forward so you don't have to worry about that. Let's call this our page 2. Page 2. So basically we are saying the proof now of power rule. We're basically saying f of x, we are told this is x power n. So we're going to say, therefore, let me stretch a bit on the left here. Therefore, f of x plus h, we know that this is going to be x plus h to the power n. Where there's x, you put x plus h. And this expression here is what we've seen. It simplifies to, I'm going to indicate, because it's in landscape, let me try to indicate all the terms. So I'm going to move backwards because I need more space. This is going to be equal to x power n plus n x power n minus 1 h plus n minus 1 all over 2 x power n minus 2 h squared plus n minus 1 n minus 2 all over 6 x power n minus 3, and then we have h power 3 plus the last term. So we have 1, 2, 3, 4, and term number 5, the last one, is n minus 1, n minus 2, and then I have n minus 3 all over 24, and then I have x power n minus 4, h power 4, plus 1, 2, 3. It's basically this expression here that I'm rewriting all the way up to there. That's the one you can see here. Right, therefore, let's move now to f prime of, therefore, f prime of x, the formula says this is going to be limit as h approaches 0 of f of x plus h minus f of x all over h. Now, starting to write from the far left, just to make sure that we accommodate all the terms, I'm going to move back here and I'm going to say that is going to be equal to limit as h approaches 0, and I'm going to copy that expression here, of x power n plus n x power n minus 1 h plus n minus 1 over 2 x power n minus 2 h power 2 plus this term here now n minus 1 n minus 2 all over 6 x power n minus 3 h power 3 plus this part here, which is n minus 1 n minus 2 and then n minus 3 all over 24 of x power n minus 4 h power 4 plus 1, 2, 3 minus, remember here I told you must always put brackets there. And what must we put in brackets there? It's that expression. Remember, this expression here is for that part there, and we need these two. So here I'm going to have x power n, but we're saying this is all over h. Now, obviously, if you remove those brackets, you'll notice this basically cancels that part there. So I'm just gonna, for the sake of space, I'm just gonna say this cancels that. And so what do we have? In the next step, we have limit as h approaches 0. Now I'm left with n x power n minus 1 h, that term, and then plus n minus 1 all over 2. And what do we have? X power n minus 2, and I have h power 2. And then I have plus this term here, which is n minus 1 n minus 2 all over 6 x power n minus 3 h power 3, and then plus this part here, which is n minus 1 n minus 2 n minus 3 all over 24 of x power n minus 4 h power 4 plus 1, 2, 3. Don't forget that. And we're dividing the whole of this expression by h. Right, let us factorize the numerator because there is a common factor there. The common factor is always h, as you would recall from the previous videos. This is going to be limit as h approaches 0 of h, open brackets, we have n x power n minus 1. This part here, the h is gone, I have only that left, plus take out or divide into this expression, remove or divide into this expression, h into that expression. You are going to have n minus 1, and then we have all over 2. This part here is actually x power n minus 2. So let me remove my hand misbehaved there a little bit, this part here. All right, so now what do we have? What we have now is, remember now we are here, this h is gone, we have that one, which is this part here. Divide 1h here, you are left with 1h. So now you have x power n minus 2 h only, plus we're here now, it will be n minus 1 n minus 2 all over 6 x power n minus 3, and now h is going to be power 2 because 1h has been, we divided 1h out and we're left with h power 2. And then plus n minus 1 n minus 2 n minus 3 all over 24 x power n minus 4 h power 3. Remember, dividing 1h plus dot dot dot. Normally I like 3 dots, but it's where there's no rule on that one. You can have 5 dots if you want, 4 dots, but usually we write 3 dots there, which is a sign that the terms continue. And then we are saying divide the whole of this expression by h. Now these h's cancel, or that h cancels. Let's put down what we have. Limit as h approaches 0 of what? Of n x power n minus 1 plus n minus 1 all over 2, and then x power n minus 2. Remember, we're left with h there now, plus n minus 1, and then we have n minus 2 all over 6, and then x power n minus 3, h power 2, that's the term we have there, plus n minus 1, n minus 2, n minus 3, all over what? 24 of x power n minus 4 and h power 3 plus 1, 2, 3. This is what we have left. Now notice something. As h approaches 0, this term here has no h. That term has one h, two h's if you like, and then 3. The next one will have 4, 5, and so on. So every term from here going that side will have an h. And so as h approaches 0, all these terms collapse and you're left with only that part there. So our final solution then is going to be, this is equal to n x power n minus 1. This is basically what we intended to prove as the power rule. Remember what we said as far as power rule is concerned? Here it is. That if f of x equals x power n, then f prime of x must be n x power n minus 1. So that is the story of the power rule. And if we use what we call Leibniz notation, we're basically saying, so this is what we're saying, that if y equals x power n, then dy dx must be equal to n x power n minus 1. And the proof is what we've just given you here by using first principles. And that's the proof. Right. As far as this video is concerned, I'm going to stop here. I'll come again with another video where we will look at typical exam questions, and I'm going to be answering the 2024 question 8 in final exams for grade 12 in the Republic of South Africa. I'm going to be answering question number 8. It's purely differential calculus, first principles, rules of differentiation, and they have added a bit of functions, just about 4 marks. So we will answer that one in my next video. After that, I will move on to talk about the product rule, the quotient rule, and then finally the chain rule. And then we're going to look at techniques of differentiation, covering all the way from high school up to university, first year and second year. Yeah, so if you're new to this channel, please support us. There is greatness, like I said in the previous video, there's greatness in humility. We have not so far tried and to decorate these videos and all that stuff, but the content that is covered here, I challenge anyone that watches these videos. The content and the authority we have in mathematics, statistics, physics, and chemistry. Those of you guys who know me will actually attest to what I'm trying to say. So support us, and we trust that we will make a contribution towards your achieving academic goals. All right, God bless, and see you next time.